the unit in various cars, but also the tools you need to program the unit. So I'm like, that's perfect. That's what I'm going to get. And I started looking around for remotes. So with remote starters, well, you could use the factory remote. Your range would then be limited to the factory remote. And you can get aftermarket remotes with these units, and they'll have advertised ranges anywhere from like half a mile to a mile and a half. But from the reviews, it's apparent that those are advertised ranges, and in the real world, you see much less than that. And the problem is, as I said, she travels for work a lot. And my concern is she's not going to be able to start her car from a mile and a half away while she's at the airport. There's a lot of concrete. So I'm thinking about, like, you know, what would be great is if she could just pull out her phone, open an app on the phone, and hit start. And so I look around Ford's list of third-party vendors who integrate with their system. And I find this one called My Car. And what it is a little cellular unit with a GPS in it that you can put in the car and you hook up to the remote starter. And then this provides the capability of being able to pull up your car in an app on your phone as a picture of what your car should look like based on its make and model. You can start the car, unlock the car, do anything you can do with a key fob. Like, that's perfect. When the plane lands, she'll be able to start her car. By the time she gets to it, it should be warm. So at this point, let's talk a little bit about how remote starters work. In order to understand remote starters, we first have to understand how cars start. Traditionally, cars start off of using a keyed switch. It's just a keyed switch. There's nothing fancy there. When you put your key in the ignition, you're completing a circuit when you turn it. So when you turn into the accessory position, you're completing a circuit that will power up the interior of your car. When you turn to the crank position, you're powering up the starter motor. And this was true up until around the mid-90s. Around that time, vehicle immobilizers started to become fairly popular on the US market. And an immobilizer, well, it may sound fancy, it's just an electronic lock. So you have the mechanical lock that is the key. And then you have an electronic lock that is a transponder and something to read that. And if you don't unlock the electronic lock, your car won't start. So in the slide here, on the left side, there's a key with a overmolding. And on the right side, there's a key with, it's just metal insert. The one on the right, just actually the mechanical components, whereas the one on the left can actually unlock that electronic lock that allows your car to start. So why do I mention this? Well, remote starters today have to bypass the immobilizer. It's necessary for the remote starter to work if you want it to work in a modern car. And so if we look at how you can hook one of these systems up to your car, here's an example from Ford's documentation showing how the unit I got, the EVA one, gets hooked up. So on the lower left side, there's a couple lines that are labeled IMO. Those have to do with dealing with the vehicle immobilizer. And then if you go to the very top on the right side, there's a couple lines labeled CAN IMO. Those are connections to the vehicle's CAN bus. The reason remote starters connect to the CAN bus is to reduce installation costs. Because it's fewer connections your installer has to make. So if they can read data off the CAN bus or they can send commands over the CAN bus, they're motivated to do that because, again, it reduces installation times. On the left side of the screen at the very top is a bunch of GPIO. These are just related to controlling or reading information about the car. So, for example, when you hit the lock button, maybe you want the lights to flash and the horn honk. That can be controlled through these GPIO. And then at the bottom on that side, that big clunky connector is the high current interface. And what that does is bypass the mechanical side. So, as I said, when you turn your key, you are completing a circuit. That big chunky connector there allows those circuits to be completed with simple release inside of the remote start unit. So here's just a couple pictures from installing the remote starter. Basically, it just consists of pulling off the steering wheel column, making a couple electrical connections in the footwell. It's really not that complicated. It looks fairly daunting, but it's not that hard to do. The remotes themselves get hooked up over what Ford calls data link. It's a proprietary protocol. Really, it's just 5-volt UART running at 9600 baud. And it just connects via a bus. So these two remotes here that I'm showing, we'd be connected to the same UART connection. So sometime after installing the unit, I start thinking, you know, I wonder how this affects the security of that vehicle. Obviously, it has to bypass the immobilizer, but how secure is this? Not only the cellular side, but the remote start side. So I start looking online to see if maybe Ford publishes the protocol for their data link, so I can start looking at it from that side. And I go to the forums, and people have actually asked for the protocol, and consistently they're told no. You don't give out that information. One of the more entertaining responses I saw with it was this one, where they say, the Evo is not meant to be used as a hobbyist toy. It's meant to be used as a tool by professionals. So, I'm a professional of sorts. I set about building my own car on my workbench. So I got a second unit, put together a breadboard that represented a car, some switches to represent the ignition, momentary buttons to represent the brake pedals, and a bunch of LEDs to represent various states. I get everything wired up and I hook up a FTDI device and start monitoring the data link. And I'm capturing data, and at first it looks something like this. I mean, okay, it's not really apparent what's going on here, but if you squint your eyes just right, you can tell there's definitely some structure here. Paying a bit more attention, I notice that whenever I press a button on my remote, the message that is sent by the antenna to the remote start unit always starts with 0C and ends with 0D. So if we just split what we're receiving based on 0C being the start and 0D being the end, we end up with something more like this. At this point, it's clear there's some structure here and we can figure out what's going on. So putting in a bit more time and being a bit more diligent about keeping track of what button I pressed and what message I saw, eventually I'm able to put together a spreadsheet where I figure out what each of the commands and each of the messages look like. And so here's just a simple breakdown of what a typical command looks like over the data link protocol. When you press a button on your remote, the antenna sends your remote start unit a command that looks like this. So you have a start sentinel, that's at 0C. You have 2 bytes that represents the direction, or at least I think that's what it represents. That's somewhat interesting because UART is already directional. There's already a transmit and receive line. So that's why I've labeled it garbage, just treat it as a constant. Following that, we have a single byte that represents the command the user would like to run. So this could be unlock, could be lock, start, stop, panic, anything that you can do from the remote will have a command associated with it. Following that, we have a payload. In the case of messages coming from an antenna to the remote start unit, this payload is almost always going to be an address or ID that identifies the remote or antenna that the message came from. If the remote start unit doesn't recognize an ID, it will ignore the command. And to get a remote start unit to recognize the ID, there's a multi-step procedure that involves putting the key in the ignition, turning it on or to the accessory position, then hitting the brake pedal some number of times, pressing some buttons or nodes. It's a procedure, doesn't really matter, but it learns the ID at that point. And then if we look at the end of the message, it ends with a checksum and that end sentinel that we identified earlier. So now that we understand how the protocol works, what can we do with it? So to show this, I have a couple videos. Do we have sound? Let's again.
Guys, anything? Explain. Oh.
Okay, let's try this again. Still no sound. It's plugged in. Okay, I guess we're just going to be talking through this then. So what I was showing you there is start back. Okay, so that white box there is a development board I have that's running, that is a particle development board that's running firmware I wrote that understands the forwarded protocol. and allows me to interact with the foreign remote start unit. So what I'm showing here is I send an unlock command to the car. Well, you should have seen the command in the previous one. The unlock command doesn't work. So the remote starter doesn't yet know about that antenna. So as I mentioned, it's just UART. And one of the things with remote start units is they'll often support what's called two-way communication. So they're able to tell the remotes about the state of the car. For example, if the car started or stopped. And to do this, the remote starter sends a message back to the antenna. And when they do this, they include the address of the antenna they would like to send the message to. Now the problem here is because that's going over the UART connection and it's a flat bus, anyone on that bus can see the address being sent. So in my firmware, I have the capability to clone an address. So if you turn on the clone mode, at this point it really lights out. At this point we need to generate a message. To generate a message, we can just simply open the car's door. So by opening the car's door, the car sends the remote starter a message, or sends the antenna a message saying that the door has been opened. At this point in the video, the alarm is going off. You'll just have to take my word for it, but it is. We've also managed to clone the antenna because it's attempted to communicate, or clone the ID because they attempted to communicate with the antenna. Now when we send unlock, the alarm shuts off and the car unlocks. Okay, let's try this again. Oh. It's going great. Okay, so where's my mouse? Wow. Hey. Okay, I'll let you see. So what we have here is a Super Impreza that has a ported 1 remote starting alarm system installed and plugged into the antenna. The link bus, I have my particle. And if we send an unlock command from the particle, you'll send the command, but nothing will happen. What we can do then is we can just clone an existing antenna. So if we tell the firmware that, hey, we want to clone an existing antenna, now we just need to generate a message that's going to call the remote start unit to reach out to one of the antennas and try to tell it something. So in this case, that's as simple as opening the door. Now the alarm may be going off, but we've managed to clone the address. Now we can just send an unlock command, and we've unlocked the car and disabled the alarm. So at this point, we've managed to send a command to the remote start system, get tower, all without the key. So now let's try starting the car. Okay, now let's say we want to actually start the car. Normally, if we just type start and we try to run the start command, it won't work. And the reason is this car is a manual transmission. And remote start systems will normally have a special procedure when it comes to manual transmissions. In this case, it's you have to, with the key in the ignition, hit the remote start button while the car is running, and then you can pull the key out, walk outside the car, and when you shut the door, the remote start will shut off the engine, and it will lock the doors. And this is to keep the car from ever remote starting while it's in drive, because that's dangerous. However, it's not really a security feature, and
To prove that, it's as simple as if we take a look at one of these remote start units. What makes it work in the manual transmission mode is this loop of wire here. If you cut this loop of wire, it switches to the automatic transmission mode. And that case doesn't require any special setup. So you just saw the start, didn't do anything. So what I'm going to do is I'm going to reach under the dash and I'm going to cut this connection. To make that easy for this demo, I've just installed a switch on this loop. Okay, the connection's been cut. Now, if we rerun the start command, this time, the car starts right up.
Jeez.
So at this point, we have a car that we can start. We can add the one to it. We can start without a key. But if you have a remote start command, you know that that's not everything you need to do. There's normally a key takeover procedure. Normally, well, you shouldn't be able to drive away in a car that's remote started. But let's say we want to drive away in a car that was remote started. How would we do that? One of these times we'll be yes.
So to disable the wheel lock, I put a normal key in the ignition. This does not have the transponder in it, so it cannot actually be used to start the car. However, we have it in the ignition, and we actually only have it in the accessory position. And that's enough to disable the wheel lock on the Supra Impreza. You don't have to go all the way to ignition to get the wheel lock to cut off. And now,
okay, sorry, not my computer, don't know what's going on. Okay, I want this video. Let's try this again. There we go.
so now that we have the car started without a key, let's say we want to drive off. This is where it gets a little bit tricky because these remote start systems will have some form of key takeover. And what that means is the owner can put the key in the ignition, turn it to the ignition setting, and then transfer over to that. But if we don't have the key, the moment we press the brake pedal to drive off, the car will shut down. Now, if we want to get around that, it's fairly simple. We just have to figure out how the car is telling the remote starter that the brake is being pressed. In this case, that's happening over CAN bus. And plugged into one of these ports back here is the CAN bus connection. And if we just unplug that while the car is remote started, he'll no longer care that the brake is being pressed. Now, because that's under the dash, what I'm going to do here is I'm going to start and unlock the car. So I can get out and get that disabled. I'll show you that in a second. Okay, now we're under the dash here, and I have my remote starter right down here. And there's a little white connector here, and that's the connection to the CAN bus. If I unplug that, you'll see that the car is still running, and we still do not have a key in the ignition. And at this point, if I get in the car and hit the brake, so if I press the brake, the car will not shut off, and that's because it doesn't know the brake pedal is being pressed. So at this point, we can get in the car, we can put the car in drive, and we can proceed to drive off in the car, all without a key.
Okay, so there's an important note to make there. And that was that click you heard at the end. That was actually the wheel lock of the car itself engaging. So the wheel lock is entirely mechanical. So we can't defeat that electronically here. You would have to use something mechanical to get around that. So breaking the cylinder or something else. Something I really wasn't interested in doing in the car. So all the firmware for what I downloaded is available on GitHub. It'll be made public after this talk. Just go to github.com/gmax open remote start. You'll find the firmware I was using along with the schematic for my little dev board there. But now let's get on to what you're really here for, which is what happens when we add the internet to this system. Because that should make it better, right? As I mentioned, the unit I got is the My Car unit, but My Car is sold under many different names. The unit I got was branded Linkar LT by Omega, but this isn't the only brand name it's sold under. It's sold under My Car Vision, CarLink, Linkar, but also Kia. It seems for a while Kia dealerships in Canada were installing this system, or at least that's what the My Car Kia app seemed to imply based on subscription. Interestingly, that application is no longer available in the App Store. I also want to note that while just looking at My Car and Ford here, that doesn't necessarily mean other systems are better. At the same time I was doing this research, CyberGivens and Pentest partners were looking at other systems with similar capabilities, and they found very similar issues with those systems as well. Which brings me to the real question, the thing I want everyone to be thinking about, which is how does this happen? How does a product with the issues I'm about to show you make it to market without anyone saying anything? And if anyone here has an interest in looking at remote car starters, there's a couple things I want to point out. First, as I mentioned earlier, if a remote start system is misinstalled in a manual transmission vehicle, it's possible that the car can start while in gear. This means the car can actually begin moving and the engine can actually start up. And now you have a car that's moving without anyone behind the wheel. So that's obviously dangerous, but there's actually a more subtle and I think bigger risk, and that's if someone parks a car with a remote start system in an attached garage and it's remote started accidentally or without their knowledge, carbon monoxide can enter the home, and that can create a very dangerous situation. So if you do have a remote start system, you should definitely have carbon monoxide detectors. But also, if you are looking at a remote car start system, just like with locks, never start a car you don't own and that you don't know where it is, because the consequences could be dire. So looking at the My Car unit, it's this little black box with this 8-pin header. 2 of those pins are actually for a debug interface. Connecting to this debug interface, it's obvious the unit is running Linux, a fact which, as far as I can tell, the manufacturer does not disclose. If you want to drop into the Linux shell, the password is actually OE Linux 123. So if you can get one of these, there you go. But without logging in, you can use something they call the AT engine. And this lets you run AT-style commands on the command line, so you can do things like change the IP address the unit is talking to. And if we look at the diagram at the bottom where it says IP, this is actually the server that the My Car unit talks to communicate updates. And just underneath that, there's an L port. That's the port that this is listening on to receive commands. By using the AT engine and changing the IP this was talking to, changing it from one that My Car controlled to one I controlled, I was able to determine that this device is talking via unencrypted UDP. I didn't do much looking into that, but I thought that was fairly significant and interesting. So here's some more information on this if you want to pick one of these up. A couple things to note. Voltage kind of matters. That UART and well on the documentation seem to imply you can be tolerant to much higher voltages. And then the next 3 I'll tell you shows that. And you gotta be a little bit more careful. So as I said, where I live, it gets cold. And about a month after I gave this system to my girlfriend, my curiosity got the better. When I installed the system, I had a nagging suspicion that I was opening her up to some security risks. But I said, don't look at it, ignorance is bliss. Just don't think about it, just don't think about it, just don't think about it. And I was able to do that for about a month. And after a month, I pulled the cellular unit out of her car, put it on my bench, and started playing with it. And the forecast for the next week was cold, -30 Fahrenheit. And I was able to connect to Shell, get it working. And the cellular reception in my home lab is not that great. So at some point I decided I want to work on it with a different computer. And the FTDI device I'm using doesn't have a particularly on board, so I go find a different one, plug it into my computer, plug it into the remote start unit, power everything up, and all the magic smoke leaves the unit. And she's flying out tomorrow. So at that point, there's a lesson learned there. If you want to do any type of hardware hacking and you can't afford to lose the unit, always have a spare. But if you ask my girlfriend, the moral of the story may be, if your significant other is a hacker, don't let them play with your Christmas presents. So now let's look at the software. No chance of magic smoke here, I know. I fire a man-in-the-middle proxy. I disable SSL validation on my phone and begin sniffing what traffic is being sent by the application to the back end. And during the registration process, I notice it takes my email address, sends it to a web service, check to see if that email address is tied to an existing account. And it's using basic authentication, which is interesting because I haven't created an account yet. So I don't really know what to do with that. I can just file it away in a notepad and move on. I create an account, I log in, and one of the first things you do, the application does when you log in, is it calls a web service to check who the current user is. So I just call that web service with the credentials that I saw earlier that were used to check to see if my email address exists. And the response that I get back is my car admin. Now at this point, I really don't think this is the admin, because this has to be a low privilege account with a really important sounding title. After all, we all know people like this. So I create another request to start my car using this account. I hit send, and I get back 200 OK. And about 3 seconds later, my car starts right up. So it turns out the My Car admin account was an admin account, hard-coded into the mobile application. But it doesn't stop there. In the previous response, you may have seen this thing called API key. Again, from monitoring of traffic with man-in-the-middle proxy, I know that you can use these API keys in place of a username and password. If you use the fixed username API and one of these API keys, you can authenticate as that user. So I copy and paste this string into the password field on Postman, set my username to API, and I hit send. And it doesn't work. I don't get back a response. And I don't really know what's going on. I'm a little confused. I stare at it for probably a good 5 minutes, and then it dawns on me. I forgot to strip the quotes and the comma from API key. And looking at the response, there's a SQL error. And at this point, it's apparent that you could have just used basic SQL injection to bypass the entire login process and become the admin or any user you wanted. Like, this is not at all complicated. So let's have some fun with SQL injection. I don't think anyone's ever started a car with SQL injection before, so let's try that. So I got a SQL injection that targets my user account, skips the whole password thing, we'll just use SQL injection for that. Hit send, I get back my status 200 OK, but this time I was smart enough to record a video. Now the video's a little dark because I didn't realize I was going to be doing this talk at that time, so.
So if this works, the car outside should start a SQL injection.
Sorry, one of these times I'll get this right. Okay, where is the window?
And it
Oh, you have
has
it.
a command is sent.
It is dark.
So this is in my office, looking outside. You can see the reflection of the computer screen.
And there the car is starting.
Okay, so there we go. We started a car with SQL injection. But it really doesn't stop there. They didn't just have SQL injection in the login. They had SQL injection everywhere. Whether it be the URL path, query string parameters, bodies, it seemed like everywhere you looked, there was SQL injection. And looking at the error messages from looking at the SQL error messages, we can see that what we're entering as a password is being compared directly against a column named password in the database. So what this means is they have plain text passwords and SQL injection. As they say, not good, very bad. Okay, so that's enough of that SQL injection stuff. Let's see what else we can do. So as I showed before, here's how you remote start a car. You just post a command to this commands API, saying your command type of engine start. And you get back an integer ID representing the command ID. You can then pull a service to get the status of that command. And it looks something like this. And so, I get the thinking and I increment and decrement my command ID, and I notice I get responses back. It seems to be pulling any command ID. Try a couple more values, and sure enough, it's pulling back any command ID in the system, or any command that's ever been sent to the system. Now, there's not really anything sensitive here, So it's not really that big of a deal, but I get to thinking maybe there's a direct object reference that I can use to start my car. So I take the start command from a legitimate user, from my user account, and try to call it via my second user account that should have access. And I get back an error message saying 401 unauthorized, account out of hierarchy. So maybe it won't work. However, if you look at that API, there's actually duplicate information. The user's email address and their account ID are roughly corollary. Both specify a user. And if you design APIs, or rather hack APIs, duplicate information is the source of bugs. In this case, a developer could implement this in these 4 different ways. So if we look at cases 2 and case 3, both highlighted in red, those will result in direct object reference. Both of those don't properly check to see if we're authorized to run the command. So what we can do, so we tried case 2, it didn't work. What about case 3? To try case 3, we simply have to change the account ID in the URL. Previously, we were using the victim's account ID. Let's just use the attacker's account ID. So I set the account ID to be the attacker's account ID rather than the victim's. Keep the device ID as the victim's device, and send the command. And sure enough, 200 OK, I get back my command status, and a couple seconds later, my car starts right up. So what does this mean? So via 3 different vectors, we're able to basically do anything a legitimate user can do. But let's call out what that is. We can locate any vehicle in this service. We can identify the type of vehicle that is, make and model. We can unlock the car, we can start the car. We can edit the car. We can do anything. And there's 3 different ways of doing this. So obviously my car tried to fix some of this. In the case of the hard-coded passwords, it seems they just put a reverse proxy out in front of the application to hide the credentials they were using. Well, you see there's a problem with this. Reverse proxies aren't magic. They don't fix everything. And in this case, they kept the SQL injection in the backend service. And so, while I no longer have the password, I still with no authentication, could do SQL injection via the checked user. So that was interesting, and at that point I decided, okay, let's see what else is here. Let's see if they left more. And the device registration still seemed to have SQL injection. And both of these things still seem to be vulnerable up until about 36 to 24 hours ago. So, yeah. So Googling around, you may have noticed all the URLs here are m2msuite.com. So I decided I'd take Google and search for M2M Suite. And I came up with this site. This must be some type of backend interface for the MyCar system. And so, obviously, the only thing one should do when they see this is throw a couple single quotes in there and see what happens. And of course what happens is you get SQL injection. And this is months after the initial disclosure that they had a problem with SQL injection. So if you have SQL injection, you should really fix it as soon as possible. But none of this is what I consider to be the most offensive bit of the solve. And that's actually has to do with location. So MyCar has a GPS unit. It can track the location of the car. And in their application, they will gladly show you your car's current location. And that's the only way this gets used in the application. Now, if you look at their APIs, it's not just your car's current location. They seem to be storing a heck of a lot of information, much more than what is needed to keep track of your car's current location. In the case of my account, over the span of 13 days, they have a little under 2,000 data points about my vehicle's location. None of this was disclosed in their privacy policy. But it gets worse than that. Maybe you could argue this was a development mistake. Maybe this is a side effect of the way the service is implemented. There's another API where they analyze your data. And instead of just having a list of places you've been, they identify top locations your vehicle has been, frequent places you visit. Again, to my knowledge, this is not disclosed in the privacy policy. I can't find anything there that would indicate they were going to do this. So maybe this isn't that surprising though, because after a bunch of searching, I believe I found the parent company of MyCar, and they're a company called Procon Analytics. And so I went to their site, went to the frequently asked question page, and and looked at the question, how do you secure data? And to this they said, unlike public cloud environments that battle for priority, Procon Analytics uses virtual private cloud that supports only our customers and applications, with no interference from other users. This dedicated, highly secure environment ensures higher availability, faster delivery of service. When you partner with Procon Analytics, you can be assured your data is secure and protected. I really don't even know what to say to that. But if we head over to the Facebook page, they say more. There they simply say, protecting vehicle data is vital. And to that, I have to say, I agree. So back to the question that I said at the beginning of this talk. How does this happen? And maybe more importantly, as an industry, how do we stop this from happening again? So that's my talk, and at this point, I'll take any questions you have. Okay, so the question is, did they fix everything? At this point, I believe everything I reported is fixed on the MyCar side, with the exception of the privacy stuff I mentioned at the end. Last I checked, that was all still the case. I don't know. I don't have any vectors that I know of that generate SQL error messages, though I haven't looked too hard. Could you come closer so I can hear you? Sure. So when I said I could add the car, the question about was when you said you could add the car, you added parameters in like the ECU. What I was specifically referring to there was editing the car in the MyCar service. So they keep a digital representation of your car, and so that could have been edited via the direct object reference SQL injection or any of the other vectors discussed. So the question was about, do you have a push button start system in the body to unlock the steering wheel, to get around the steering wheel lock? So my car has a push button, and there is no steering wheel lock. So I suspect that if you install one of these in a push button car, you definitely couldn't apply a steering wheel.